Well, back again. Section 2.3. We're going to talk about mathematical models today. And in these mathematical models, we're going to focus in on revenue, cost, and profit functions. Since this is business calculus, we're going to talk about those. We're going to introduce those today. And equations of lines as well, which you should hopefully remember from years past. So let's go ahead and dive in to our economic portion of it, revenue. Revenue is money that we bring in by selling something. So if I sell balloons and I sell them for $3 a piece, to figure out my revenue, I would take 3 times the number that I sell. So my P, in this case, would be my price, and my X would be the number of the quantity sold. So think about R of X, or the capital R of X. Very important that we denote those differences as well, I suppose. Is X times P, or the number of units sold times the price that we sell it at. The cost would be the money required to make a product. And we split cost into 2 different types. We have fixed cost and we have a variable cost. A fixed cost is something that doesn't necessarily depend on the number of units that we produce. So you can think of those like your building, so rent. It doesn't matter if we produce 100 units or 1,000 units. Our rent for our building is going to be the same. Doesn't matter if we produce 0 or 5 million, we still have to pay rent for that month. Some other things, we have to light the place, so electric is going to be in there. We also have insurance, so we have to have insurance for our employees and for the building and all that kind of thing. Our variable cost is going to be the cost that depends on the number of units that we produce. So each of these units that we have is going to cost us a certain amount to produce. We talk about our raw product. You can also think about maybe production salary. So here, if we produce 100, we might need one person to produce 100. And if we wanted to produce 200, we'd have to bring on another person. So then our salary, our production salary, would be increased as well. Not too big on, what they're going to be. Is it going to be a fixed cost or variable cost? But just know that there are 2 different types of costs there. In order to find our cost, we take the variable cost, or the number of units, times the cost. So our cost times per unit, you can say maybe we'll just leave it as variable cost, plus the fixed cost. And that's going to give us our cost function, our original cost function. Our profit is the money that we have after we take all the cost out of the money that we bring in, or the revenue. So P of X is going to be R of X minus C of X. And I'm sure some of this is fairly intuitive for you, but we'll go ahead and do it anyway. Here we have, hey, Jenny produces some bears. Each bear she's going to sell for $40. She has a fixed cost of $1,500 and a variable cost of $10 per bear. Can we find the cost function, the revenue function, and the profit function? So it doesn't matter to me how we do these. I guess we'll put it in the order that we give them. So C of X. So remember, C of X is going to be the variable cost, and it will add to the fixed cost. So here we have a fixed cost of $1,500. And then each unit is going to cost us $10. So our variable cost, our total cost, is going to be $1,500 plus 10x. If we look at our revenue function, that's going to be the number of units that we sell times the price that we sell it at. So we're selling at $40 a unit, and we sell X units. I mean, this might be per month, per year. Doesn't really matter the time frame here. The P of X is going to ask us to take the revenue minus the cost. So I'm going to go ahead and write revenue minus cost. Not that you have to, but it kind of reminds us of what we're looking for. Here we're taking 40x minus. The biggest thing you got to remember is to put this in parentheses, because we're going to subtract off 1,500 and subtract off 10x. A lot of people like to put the minus sign, not put the parentheses. So they put minus 1,500 plus 10x, and they actually get an incorrect answer. We should get 40x minus 10x, or 30x minus 1,500 for our profit function. And then it asks us to find C of 200 R of 200, and P of 200. C of 200, we go to our cost function. We're going to plug in 200. We can do this into our calculator, or you can probably do this without a calculator for this one, hopefully. Our cost function would be 200 times 10, which is 2,000, plus 1,500. So we have 2,000 plus 1,500, or 3,500. And this is, I guess, dollars. And our revenue function, R of 200, we can do this hopefully without a calculator as well. So we get $8,000 for R of 200. Again, 200 times 40 gives us our 8,000. And then our profit function, or P of 200, we could plug 200 into here. So we have 30 times 200, which will be 6,000, minus 1,500, which gives us $4,500. Or you could take your revenue up here minus your cost. Doesn't really matter because remember, profit is revenue minus cost. So 6,000 minus 1,500, or 8,000 minus 3,500. Still going to give us that same answer of 4,500. Very important that we interpret our results. What does this mean? Well, C of 200, this is the cost of producing 200 units is $3,500. R of 200 is the revenue of selling 200 units is $8,000. And then P of 200, that is the profit of selling 200 units. That's getting pretty bad in there, isn't it? But it's the cost of producing 200 units, the revenue of selling 200 units, and the profit of selling 200 units, or the profit on 200 units. Remember, or you may not remember, but profit could be negative if our revenue is less than our cost, and if P is 0, something that you might be interested in, especially being a business major, some of you. If profit is 0, that's called our break-even point. That's where we don't make any money, any profit. We don't lose money. We're not gaining money. We're just breaking even. So we're very, very stagnant, if you wish. We might as well not do anything at all. If we're not making any money, we're not losing any money. So break-even point, very important point as we get into business, and we'll talk about it a little more as we get into things. The last thing we want to talk about is this equation, a linear function, f of 2 equals 3, and if f of 5 equals 1, can we find a linear function in the equation of the form y equals mx plus b? So all you really got to do with this is make sure that you remember that the x value is 2. That gives us the y value of 3. Here, f of 5 equals 1 gives us the point 5,1. We're asking you to find the equation between these 2 points. How do I find the equation? Well, I can find m as the slope, y2 minus y1 over x2 minus x1. That gives us 1 minus 3 over 5 minus 2, negative 2 over 3. Nope, I guess it's negative 2/3, isn't it? And then we can go ahead and y equals mx plus b, if you wish. We can pick one of these points, doesn't matter which. I'll take 2, 3. So 3 equals negative 2/3 times 2 plus b. We can find our b value this way. So 3 equals negative 4/3 plus b. Add my 4/3 over. So we got, what, 9/3. Adding that over, we get 13/3 equals b. So we know then m is going to be our negative 2/3 x, and then our b is going to be a 13/3. And that's going to give us the equation between those 2 points. And there's a quick mathematical models talking about our revenue, our cost, our profit functions, and also equations of lines. Good luck.